This is question number 4 from the MyLab Math homework number 21 over section 3.4, scatter plots. So we've been given a scatter plot that shows the median starting salaries and the median mid-career salaries for graduates at a selection of colleges. So whenever you get a scatter plot, you always ask yourself, what does each dot represent and what information do I get about that dot? So each of these dots is a certain college. And what they did is they looked at that college and looked at all the graduates and all the starting salaries, and they found the median starting salary for graduates at that college. And then they found the median mid-career salary. So after those graduates had been out there on the job market for a while, what were their salaries? And they found the median. And so this college, I don't know what college that is, but this college, graduates from this college have a median starting salary. They start just under $50,000, and about halfway through their career, the median salary is just under $75,000. Okay, and that's what the first question is asking us. Just what is the independent variable and the dependent variable? So remember, the independent variable is linked to the input. So input, independent. So the independent variable is the starting salary. And then the dependent variable is linked to your output. So that dependent variable is the mid-career salary. So we answered that question. Okay. And then it's asking us why we suppose the median salary was used instead of the mean. And this goes back to Unit 2 information when we studied statistics. So think about a college and all the graduates. Some of the graduates at that college, when they first graduate, they're not going to get a job and they're going to have a salary of $0, right? But hopefully there's not too many of those. Hopefully they're the exception or the outlier. Some of the graduates at that college are going to get super lucky and they're going to land like a 6-figure job right out of college. But that's not very likely. They'd definitely be an outlier. And those outliers, those extremes really affect the mean calculation. The mean is where you add up all the salaries and divide, and those outliers, those extreme values really affect the sum, but those outliers did not affect the median as much. So they're using the median to calculate the typical starting salary and the typical mid-career salary. Okay, now let's jump down here to some questions about reading the scatter plot. So C is asking us to use the regression line on the graph. So use the regression line on the graph to estimate the median mid-career salary and the median mid-career salary for the median starting salary of $60,000. Okay, I had to read that twice. So we know the median starting salary is $60,000. So $60,000. So I come up here and I can see these dots in that range have, median salaries starting salaries close to $60,000. And we're supposed to find a median mid-career salary. And we're going to use the regression line. That's that red line. So I can see that there's definitely a positive trend in this data. As starting salaries increase for those colleges, the median mid-career salary also increased. And those dots are pretty tightly packed around a line. So it's a pretty strong trend. It's a positive trend because it's going up. So that red regression line, think about it as kind of like the average. So if I go to 60,000 and I go up and I hit that red line and I go over, it's kind of hard to read. I go over, I don't know, it looks somewhere between $100,000 and $125,000 mid-career salary for graduates that start at 60,000. So hopefully, my math lab is going to be a little gracious with us. I don't know. So maybe $112,000. I don't know. I might have to guess and check. This graph is a little hard to read because it doesn't exactly hit that median. I wonder if I large size it. Give me 1 second. I'm going to click this and see if it's any easier to read. Okay, so 60,000 hits that red line. I come over. Oh, it's still not great to read. Oh, but it's more than 100,000, pretty close to 100,000, less than 125. I don't know. I'm going to see 112,000. Hopefully my math lab will count that right. Let's see. Let me just type that in and see what it says. So 112,000. Oh, I have to go all the way to the end before it'll count that right? Or tell me if I'm right or wrong. That's fun. Okay, well, let's just find the next answer real quick. We'll see if that one turns out to be right. Okay, so the next one's asking us to now use the equation. So we were given an equation for that regression line, and we're going to use that to calculate exactly what the mid-career salary would be for a starting salary of $60,000. So I'm just going to plug $60,000 into this equation. So to get my mid-career salary, I need negative $5,649 plus, oh, I need to rewrite that, plus 1.945 times the $60,000. I'm just going to type all that in my calculator and get an exact salary. And it should be close to 112,000 because that's what I kind of eyeballed off the graph there. But let me see. Negative 5649 plus 1.945 times 6123. Okay, my exact answer I got from my equation was 111,051. So my eyeball, the salary I eyeballed is pretty close. I don't know. It might, if I technically round that exact answer to the nearest thousand, that would round down to 111,000. So I'm just curious. If maybe I should have put that for my answer. I don't know. Let's just see. Let's just see what my math lab says on that. So let me go enter this exact answer into my math lab real quick. Okay, so it was 111,051. So it didn't count the right. Check answer. Consider also to be distributed in the company. So let's try the 111 up there. Maybe that would be, I mean, how could I read that off the graph just eyeballing so precisely? What? So we got the 111 right. We got the 1151 right. We got the B right. We got, oh gosh, I hadn't read I forgot to actually answer question B. Question B. Oh my goodness. Okay, so sorry, here, I didn't read this one. I just had something clicked there. Sorry about that. So why do we suppose median salaries were used instead of mean? So let's read through these. Salary distributions are usually bell-shaped. For bell-shaped curves, symmetric data that's bell-shaped, we typically use mean instead of median. Median we use for skewed data. So I know it wouldn't be A. B said salary distributions are usually bimodal, making the median more meaningful. Bimodal doesn't have anything to do with whether or not mean or median is a better choice. So typically, remember back in Unit 2, for symmetric data, we use the mean. And for skewed data, we use the median because skewed data has those outliers. So it wouldn't be B. It is easier to calculate median. It's not a matter of being easy. It's about the shape of the graph. So D, salary distributions are usually skewed. Yes. So because you have those unusually high and low salaries that can skew the data. Typically, it's more unusually high salaries that are going to skew it. There's a natural low salary of $0. You won't have a negative salary. But you could have unusually really high salaries. But either way, it can be skewed. So the median is more useful. Yeah. So I just didn't click the right answer there. I didn't even go to that. I was in my app over here instead of reading the answers. So, oh gosh, and in my app one, I had A highlighted. Oh gosh. Well, anyway, the good news is we read the graph, the regression line correctly, and we found used the equation correctly. But what I would do, since remember, I originally had the 12,000 and that apparently wasn't right. What I would do is just use the equation and round that answer and just make sure it makes sense on the graph because it wasn't apparently going to count my eyeballed answer there correct. So anyway, your numbers will be slightly different on your version. So if you have any questions when you try this problem, just shoot me an email and we can talk it out.